Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the CTS-233 Fall 2021 semester. This is the Cisco Networking Academy's DevNet Associate, or DevASC, course curriculum, and in this supplemental video tutorial, we're going to be taking a deep dive look at Linux command line basics again. However, our focus in this video is going to be on directory and file permissions, and specifically what each of the permissions read, write, and execute mean for a file as compared to a directory. Now, we're going to be taking a look at the chmod command. We're going to look at both the octal format of the permission bits, and then we're also going to be examining the other way that you can set the permission bits, and that's by using owner, group, and world explicit permissions, right? And we're going to be using permission groups to do that. And so there is a difference between the two types of permissions. So let's go ahead and dive in here on the command line. And so you'll notice we're right back here on the Ubuntu virtual machine. And where am I? Well, I'm in my home directory. And remember, we can tell by not even having to run the pwd command by simply looking at the prompt. However, if your prompt is not set up to display the current working directory, you could use that pwd command to print the current working directory. And so let's first talk about the different permission bits. Now, if I was to simply say ls, you can see that we've got a number of different files here, remembering that with Ubuntu, that blue file name is going to be a directory file, and remembering that Linux treats everything as a file. So we could have regular files like text files or directory files, which is what you see there in blue. So new file, if we were to list out and do a long listing on new file, what we would see are the permission bits that we've talked about before. And I've got the first bit highlighted there by accident, so let me re-highlight that. Remember, that first bit here, the dash, represents the file type. And so what we see is just simply the dash sign indicating that this is a regular file, meaning there's no special permissions or anything like that for this file. Now, the other values that we could see here that we have seen would be a D, indicating that this is a directory file. It could have an L there, meaning it's a symbolic link. Now, there are also other characters you could see there, and so let's add a few more on just to think about right now. You could have a T, indicating sticky bit permissions. And again, we're not going to go into that, but those are just some other characters we could see. You could also see an S, which would be for the set UID or set GID permissions. So set user ID or set group ID permissions, meaning that the file would be running with those permissions. But we just have a dash because it's a regular file. And so here we see sort of the default file permission set. And I'm going to talk about the UMask and how we end up with these default values as well in just a second. But you'll notice that they're grouped in 3 groups of 3 bits. And so we have read, write, and then the dash sign. And we have read, write, and the dash sign. And then we have just read and dash dash. So to recap, remember that the first 3 permission bits, which are those 3 bits, those apply to the owner of the file, and I'll just leave it with an O right there. So they apply to the owner of the file. The next 3 permission bits apply to anybody who's a member of the group, and the group is over here. So the group is just Travis P. Bonfili. The owner is Travis P. Bonfili, and then the final 3 permission bits here apply to the world. Sometimes you'll hear people say or other. I'll usually use W so that it's different than the owner. And so then we have the world. And so this is everybody else. This is the file permissions that apply to somebody that's not the owner and that's not a member of the group. So for example, if your username was Bob and your group was user, this is the set of permissions that would apply to you. So let's talk about what the permissions mean. So on a regular file, like we see here, the read permission is exactly what you think it would mean, is that I could display the contents of the file. I can read what is inside the file. And then write is exactly what you think it would mean. It means I can change or modify what is inside the file. And execute, again, on a normal file means exactly what we think it means. It's that we could execute or run the file if it was a shell script or maybe a Python file, Python script inside the file. And so I'll just say exec. And that means we can execute it. Now, again, these are the meanings of the read, write, and execute bit when we're talking about a regular file like new file. When we're talking about a directory file, such as public, and we'll just use this as an example. Read means that I can list the contents of the directory out using a command we're familiar with, the ls command. W means that I could add files, or you can think of it as modify. I could modify the directory, excuse me, by adding or changing, removing files from, and I'll say rm, from the directory. And then execute is an interesting one. Execute means that I can cd, I can change directories into that directory. And so these are what the permission bits mean when they're applied to directories, right? And again, this is a directory. I'll put dir here. And this is just a regular file. And so let's take a look at some examples of how this would work. And then we'll talk about the change mode command, or the command you commonly hear referred to as chmod. All right, which stands for change mode. So here we are on the command line, and you can see that this file has read, write, but the execute bit is not on. So let's test. So can I read the file? Can I cat what is inside that file? In other words, can I display to the screen what is in that file? And there it is. And remember, we just redirected the etc host file, sort of made a copy of it, if you want to think of it like that, into this new file. And it says I can write to the file. So I'm not going to go into an explanation of the VI editor right now. And technically, we're talking about Vim, which is VI improved. But let's dive in here and say new file. So can I change something, right? So let me delete a few lines out of this file, right? We got all this IPv6 stuff, and maybe I'm going to put down here something I always like to do, end of file. And then we're going to save that file. So now when I read the file, so I could cat the file out, we'll say cat new file. You can see right there that the changes I made, because I have write permissions, took effect. Well, let's go back into that new file and let's do the following. So I'm going to go ahead and delete some things here. And we're just going to go ahead and say echo, and let's just say hello world, right? And let's save that. So now if I clear my screen with the clear command and I say cat new file, you can see that all that's in there is that echo statement that says hello world. So I can read the file, I can write or modify the file, but when we look at the permission bits, oops, sorry, we didn't want that. We wanted ls-l new file. I don't have execute permission. So what would happen if I tried to run new file? You can see it says command not found. Now, this could be because my search path, which is something else we'll talk about, is not in or does not have my current working directory. So how can I represent my current working directory? Well, I could say /home/Travis P. Bonfili /new file, right? I could simply put the absolute path name to the file and try to run it. And what do we get? We get permission denied. Now, what would be a quicker way to represent my home directory? Yeah, I could say because again, we're talking about my home directory, which happens to be the current working directory in which new file resides. So I could represent my home directory like that and say / or tilde / to separate the directory structure from /home/Travis P. Bonfili / and then the name of the file. But again, we get permission denied, and this would be expected. I'm trying to run the file as if it's an executable file, as if it's a script of some kind. And we get permission denied. What is another way I could try to execute that file? Because it's in my current working directory. So I could say /new file and hit enter. And we still get permission denied. So again, kind of driving home a couple of things here, reinforcing the shortcuts we could use due to the situational awareness we have about where we are, where the file we're trying to execute is located, and those special characters, the dot representing the current working directory, the tilde representing the home directory, and then that sort of absolute path name representation there of /home/Travis P. Bonfili, which again, you would never want to be typing stuff like that out all the time. You'd want to use these shortcuts that we're using here, the tilde or the dot. So back to the permissions. We're getting permission denied because the execute bit is not set. So how do we change the permission bits? Well, let me clear the screen and let's pull up the ls-l on new file here. And we deal with the permission settings in one of two ways. Now, I am a huge fan of the octal approach because I find that to be much simpler to deal with when I'm making permission bit changes. So let's talk about the octal approach. And that is, we're going to be dealing with each of the three possible individuals who could be, or who apply to the permission settings. So we're going to have a number that represents the owner and what their permission settings are. We're going to have a number that represents the group, and we're going to have a number that represents the world or everybody else. And so if you're coming from the networking field, you should be familiar with binary, right? And so we're just simply going to be treating each of these as their own binary bit. And so what do I mean by that? Each of the permission bits is their own binary bit. Excuse me. So read has a value of 4. Write has a value of 2. And execute has a value of 1. Because remember, if we're looking at these as being read, and I'll put it underneath here, and then write, and then execute, if this is the rightmost low order bit, and the bit is on, it would have a value of 1, and then a value of 2 for write, and a value of 4 for execute. So if there was some other permission bit over here, right? Let's, permission bit Y or whatever, it would be 8 and then 16. However, we're dealing with octal in terms of the sense that when we add these together, right, we get 4 plus 2 plus 1, we're going to end up with 7. And again, we look at it as just binary values that we have here. And so each of the possible groups of bits can have a maximum value of 7 and a minimum value of, if none of the bits are on, 0. And so then it's just a matter of working the combinations out that could exist. So 0, and I should probably start putting a line so you don't confuse that with the owner. So 0 is going to be dash, dash, dash. If you used a 1 in the permission group permission settings for the, we'll just talk about for the owner or for the group or for the world, it would look like the following. It would be dash, dash, X. And then 2 would be dash, W, dash, 3 would be dash, W, X. 4 is going to be read, dash, dash. 5 is going to be read and then execute. Again, 4 and 1 give you 5, and this is the 4 position, and this is 2 and 1 give you 3. And then 6, excuse me, give you read and write, 4 and 2 with 1 being off. 7 is going to be read, write, and execute. And so the reason I excuse me, earlier said octal, yeah, it adds up to 7 here, but look at how many possible combinations we can have. There are 8 possible combinations. So if we wanted somebody to have read, write, and execute permissions, that individual would get a 7, right? For whichever group of permissions we're talking about here. And so now let's go through some examples. And I'll actually, excuse me, leave this on the screen. And actually, let me go ahead and remove this. We'll clear the screen. And so now let's take a look at some examples. Now, the chmod command or change mode command, you could say man chmod, and this is going to give you the man page. And you're going to get a lot of information about this if you wanted to come in and read. And you can see there are some variables that you can use. Now, that dash dash help, if I said chmod dash dash help, that's going to give me a little bit more information, or I should say, it's going to give you additional information in a different format, and it's going to show you the octal mode, right? So there you have it. That's why I'm referring, I typically say, you look at the binary values, but we're talking about the octal mode. So let's clear the screen. Let's go back to ls-l on new file. And what if I wanted to change the permissions so that, and we'd say chmod, so that I can read and, I can only read the file. Somebody in the group can't do anything to the file. And then if you're not in the group and you're not the owner, you also can't do anything. And then I can say new file. And this is how we use that octal mode, right? Basing it on those binary values that we can calculate. So again, 4 is simply read, and then 0 is nothing, and 0 is nothing. So it's going to be R dash dash, and then again, all dashes for everybody else. Because if I simply say ls-l new file, you can see that only I can read the file. Well, let's test that. What if I say cat new file? And it just says echo hello world. Okay, well, what if I try to run this new file? Permission denied. And this is important because a lot of learners get confused. They think, well, I own the file. I can run it whenever I want. Well, if you have execute permission. Now, you'll also notice we don't have write permission on the file either. So what if I said vi new file? And this is simply allowing me to try to modify it. And I'm going to add, look, and you can see, and I like this about Ubuntu, right? Take a look at the warning we're getting down here. Changing a read-only file. Well, what does that mean? So I've added all these additional echo statements in here. Well, let me try to save it. Yeah, read-only option is set, right? So it's set to read-only. It says add the exclamation mark. So I could say, let me write the file and quit out, and I'll put the exclamation mark to try to overwrite it. New file can't open file for reading. Press enter or type a command to continue. So you'll notice it's not letting me override the fact that I don't have write permissions, even though I'm the owner of the file. So let's display the file again. And there it is. It wouldn't let me modify it. It wouldn't let me write to the file. It won't let me execute it because, again, the execute bit is not set. And this is problematic, right? Because as the owner of the file, I want to be able to do those things. So here's an interesting scenario. What if I did this? Chmod 000 new file. Well, what is that going to look like? It's going to look like this, where nobody, right, has permissions to do anything. So what if I try to cat new file? Permission denied. What if I try to, well, we already saw if I try to write or if I try to execute it, I won't go back into the file to change it. We saw that. But if I try to execute, permission denied, right? However, as the owner of the file, I could change the permissions on that file to enable me to be able to make changes. But again, you'll notice you can take away all permissions from the file from yourself. Now, that might fall under the stupid Linux tricks category. However, that's a question that learners typically ask is, well, what if I remove all permissions? Does that mean that I can't change the permissions back to do something else like chmod 744? So again, we're using the octal mode approach, which is just simply taking a look at which permission bits we want to have on for each of the 3 categories of permissions we're dealing with. Now, here's another question that users will ask or learners will ask. What if I said 007, right? 007 on new file. Because, and I'll clear my screen, ls-l new file. Because now the question is, well, the owner has no permissions, the group has no permissions, but everybody else can read, write, and execute. And the reason learners are asking this question is because they want to know, well, you're the owner and you're in the group, but the permissions are set for everybody else, so you should be able to look at that file, right? Wrong. And what this means is that if you're not Travis P. Bonfili, and if you're not in the Travis P. Bonfili group, then you could read, write, or execute that file. But if you are the owner, Travis P. Bonfili, or if you are in that group, which is also named Travis P. Bonfili, you have no permissions. So as the owner and a member of the group, that is what applies to me. Not the fact that, oh, well, you set it for everybody else, which is why I stress that everybody else, not me and not in my group. These last 3 permission bit settings apply to everybody else, the rest of the world. So again, you might think, well, stupid Linux trick, but no, these are important things to understand when we're talking about the permissions on a file. So let's go back to something a little bit more useful to us here, and let's do that chmod 700. So now what does new file look like? Well, it's got read, write, execute for the owner, me. If you're in the group, you're out of luck. You have no permission settings. If you're everybody else, you are also out of luck. You have no permission settings that apply to you. And so let's go ahead now and say /new file. Excuse me, and it does exactly what we think it would do. It would echo out. We just executed the file. If I said chmod 644 on new file, and then we say ls-l on new file, you can see the execute bit's been taken away. So now when I try to run this file by providing the file name, and again, I'm providing the relative path name to the file, new file, we get permission denied. I can't execute, excuse me, getting a sore throat here. I can't execute that file. So let's go ahead and see. So now we've seen what the permission bit settings look like when we've applied them to a regular, normal, non-directory file. Let's take a look at the permission bit settings on a directory like DevNet. Sorry, I didn't want to do that. Let's clear this out. ls minus L. And here is DevNet, right? And you can see it's a directory, and the default permission bit settings, which gets set with a umask environment variable that we haven't talked about yet, get set to 7, right? Read, write, execute is 7. Read, write, execute 7. Read, execute 5. So they're getting set to 7, 5, 5. And so what that means is, what does the read permission on a directory mean? It means I can list out the contents of the DevNet directory. So let's test that, right? Let's make sure that what I'm telling you is actually correct. So I'm going to say chmod 007 on DevNet. And again, I'm removing the group permissions and the owner permissions. So there's no question here that if I say ls DevNet, I'm going to get permission denied. I cannot list the contents of the directory out. That is the read permission bit. Because what if I did this? What if I said chmod, and let's do write and execute for both? And what would that be? 3, 3, and I'll do 7 for the world on DevNet. Can I ls DevNet right now? No. So that should prove conclusively that the read permission bit setting on a directory allows you to list the contents of the directory out. So I still have write and I still have execute. So can I cd into DevNet? And I can. Well, let's get back up one directory, because now what we want to do, and let me clear the screen here. Now what we want to do, and if I said ls-l, and I'm going to do grep on DevNet here so that we only see that one directory I'm interested in. So now what we're going to do is let's go ahead and say chmod, and I'm going to put back the read permission bit and the execute permission bit, but not the write. So what would that be? Read and execute, 4 plus 1. So let's do 5, 5, 5 on DevNet. So if I rerun that command, you can see we've got read and execute. So can I list out the contents of DevNet? Yeah, because I've got the read permission bit set on the directory for me, the owner of the file. When I say file, we're talking about directory file. Now, the execute bit is set, so can I cd into DevNet? Yeah, because the execute bit is set. Let's try to create a file in here, and I'm looking at the file names that exist right now, and let's just say file D. Permission denied, because I don't have the right permission bit set, the W, for me, the owner, or for the group. And again, I'm doing that intentionally because I am the owner and I am in the group, right? So you can see that that is the impact of the right permission bit. So let's go ahead, and do we need to CD back up to change the permission? Oops, sorry, and let's do LSLA, and let me clear the screen here. What I was trying to show is here is the current working directory. Remember, you're not going to see the name of the current working directory in the current working directory. So you'll notice we have nothing here in this listing of all the files, directory or otherwise, that say DevNet, because we're in the DevNet directory. However, how do we reference the current working directory? Well, we can do it with a dot. So could I do the following? Change mode, and let's give ourselves write permission, but let's see what happens if we only give ourselves write permission. How would I say change the mode to 200 on this current working directory? You've got it. So I don't have to CD back up into the home directory and then make the change on the DevNet directory. I can do it right here. How can I prove that that was just what was done? Well, we can't, right? Because I'm trying to list the contents of the directory out. What permission bit do I need to do that? Well, I need the read permission bit. So that tells us that, yes, we definitely tweak the permissions on that. So what if I went up a directory? Now, I wouldn't be, or what if I was to say ls-la ... Because if I go up a directory right now, I'm kind of hosed because I can't cd back in because I don't have the execute bit set. So how could I check the permissions of the parent directory and all the contents of what is in that parent directory, which happens to be my home directory? Yeah, I can't. Because I can't get out of this directory, right? But could I touch a file in here, right? Let's say touch file, and what was I going to do? D. No, permission is denied. I can't even write to this directory, right? And this is an interesting one. So I'm in the directory. Can we get back to my home directory? I can. So let's say ls-l and grep on DevNet, and let's see what the permissions are. You can see that I only had write, but it wouldn't even let me do that when I'm in the directory. But what if I was to say chmod, and let's do 600 on DevNet. What if I had the read permissions? Can I get back into DevNet? No, because I don't have the execute bit set to cd into that directory. So as you can see, the meaning of read, write, and execute are very different from a regular file, like a text file. They have one meaning. And when we're talking about a directory file, they have a very different meaning, right? So let's go ahead and do chmod 700 on DevNet so that we can cd back into DevNet. I can list out the contents and I can create a new file, file D, in this directory, right? And sorry, I usually do I on there, but let's just say ls-l, right? And so you can see that file D has been created, and those are the default permission bit settings. Now, one thing that you can't do, because now we're going to transition to using the letters, which I've never been a fan of the letters. I just think they're very cumbersome, because for me, it's super easy to simply say, oh yeah, read, write, execute, 777 on file D, right? So everybody can read, everybody can write, everybody can execute, and we can do that. Or let's just say that the owner in the group can do everything to the file and the world can't do anything, or the world can only read the file. Oops, sorry. The world can only read the file. And so the numbers for me have always been easier than what I'm about to show you. However, there's a reason, because you might be asking yourself, okay, well, you're going to show us how to use letters, right, and you've already seen read, write, and execute, but now we're going to talk about U for owner, G for group, and O for others, and A for all users, right? So, and that's where, like I said, it gets confusing. However, there is a reason for that, because what if, I came to you and I said, hey, on file A, B, C, and D, I need you to change the permissions, and let's say that the permissions right now are 774. If I came to you and said, hey, change it so that the group can only read the file, right? Well, you could do that by saying chmod, and then you'd have to be like, okay, well, it's still going to be 7 for the owner. If group can only read, that would be 4, and then the world would also be 4, and then you would say file A, and you could do some regular expression type stuff, but I'd say file A, maybe file B. So you get the idea. What you cannot do is I couldn't do this. Say for file B, right? Because if I put the number by itself using the octal form, how does Linux know? Are you talking about the owner of the file changing the permissions to 4 so that it's only read? Are you talking about the group? Or are you talking about everybody else, the world? Right? So chmod 4, what happens there? ls-l on file B. It did it for everybody else. So chmod, when given a single number, looks at the world, it sets it for the world as read only, and then it wipes out, it assumes leading zeros. So what if I reran that command and did a 7 here, right? And then we say ls-l file B, take a look at what's happening. So yes, I'll do air quotes, it works, but that's not what we wanted. Because again, Linux doesn't have any way to know, are you referring to the group or the owner? So what does it assume? It assumes that when you use a single numeric representation here with the octal mode, that you're talking about the group, and that it assumes that the other permission groups, in terms of the group and the owner of the file, that the permission settings are going to be zeroed out. And that's not what we want. So now let's introduce these letters with the chmod command, right? Or change mode command. So if I was to say, let's do 755 on file, we'll work with file A, ls-l file A, and you can see the permission bits have been set to 755. So what if, again, so here's where I would tell you, hey, do me a favor, just change the permissions on the owner so that it's 4-5, so that the owner can only read, right? So again, you might be able to say, oh, okay, if the owner only reads and then everybody else has the same, file A, yeah, that would work. However, you could also use U, right? The letter U represents the owner. And if it's that the letter U, if the letter U is the owner, we could then subtract or add permissions. So I could say for the user, for the owner of the file, remove with a minus sign. And I think we said we're only going to allow them to read. Remove write and execute on file A. And then we say ls-l file A and take a look at that. It removed, because of the minus sign, the write and execute permission bits from the user. Right? From the owner, right? You think user is the owner, from the owner. Well, what if I wanted to add, right? So let's say chmod for the group, I want to add write permissions to file A. File A. So I would say G plus W. Again, I'm only impacting the group file permissions, right? Then what if I told you, well, hey, I need you to remove execute and read from the group. So I would say G, remove execute and read from file A's permissions for the group and only the group. So now the group only has write permissions, right? And so this is how we can use the letters that represent the different groups of the different groups of permission bits. So U for owner, G for group, and then O for others, right? They went with O for others. So if you look at let's say we want to remove all the permissions we want to remove all the read and the execute from the others, and we'll remove read and execute from file A. And now we say ls-l file A, and the world or others has had all their permissions removed. Well, what if we want to let them, we figure, hey, okay, let's let them read. So I could say O plus R on file A. And then we say ls-l, and you see the read permission bit has been added back. So U for owner, G for group, O for others, and then A for all users. So if you look at the permissions we've got set right now, if I came to you and said, hey, throw the execute bit on here for everybody else. And this is where this might have advantages over, okay, well, if I add the execute, because then you might look at the existing permissions and say, okay, well, if it's already got read and I have to add execute, that's going to be 5. And if it's got write and I add execute, that's going to be 3. And if it's got read again, then that's going to be 5. Instead of having to do that math in your head, right, this might be a nice use case to say, yeah, everybody is going to get execute permissions on file A. Boom. A, add, execute, right? A for all, ls-l, file A, and there it is. All the other permission bits have been maintained. We just added the execute permission bit. And so again, the use case for this is the use case that we couldn't solve with the octal mode, which is if I was to say only change this bit for the owner or only change that bit for the group, right? Or change the permission bits for just the owner or just the group. With the octal, it's a little bit more difficult, right? Because you can't just pick off like one setting. However, here we can. We can specify whether it's going to be the owner of the file, the group of the file, everybody else, the world, or all of the 3 possible groups of permission bits. And then you can say, take away just the execute from everybody. Take away just the read from everybody. Take away just the write from everybody on the file. Or, hey, add the read for everybody, or add write for everybody, or add execute for everybody to file A. And let's do minus. We'll take away the execute from everybody on file A. And we say ls-l file A. And there it is. The execute permissions have been removed for everybody. So it's not that there aren't use cases. You're going to pick one of the ways to do it. And it's interesting because, like I said, I always default to the octal mode. But typically what I do is if I am in a directory and I've created a text file, which by default, like let's say it's a script. So let me go back to my home directory. Let's list things out. So let's say the file there, you can see, and in fact, new file, we won't even do the chmod. If I was to say ls-l on new file here, which is our little script that echoes out hello world, you'll notice by default, the permission settings here, well, again, we've been messing with these. Let's do this. Let me remove new file. And then let me create a new file. And then let's say ls-l new file. I was getting ready to say the defaults. So you can see the defaults are 664. And there's a umask value that is set that allows that to happen. Now, I'm going to deal with umask in another video, but this is where the default permissions are coming from, is this umask setting here. So you could say man umask if you wanted to take a look. And there's no manual entry for umask. Okay, unfortunate. So I will definitely do a video on this, but to wrap this up, the default settings are 664, which means if I go into new file and I create echo hello Linux, right? And we save that file, and then I say, well, I want to run that file. So let's go ahead and say /new file. We get permission denied. Typically, I don't use the octal form here. I'll say chmod u plus x, meaning add execute for the owner of the file to new file. And that's typically how I quickly change scripts that I'm creating that I want to be executable. I simply just do chmod u plus x. I don't do 7 and then have to look and say, was it 764 and then type that out. I'll just say chmod u plus x, new file, because then we can execute our file and it runs as a shell script. All right, well, that is a pretty comprehensive introduction into directory and file permissions. We talked about the differences between the application of those permission settings to a directory and to a regular non-directory, and I use the example of a text file. All right, well, that is going to do it for this video tutorial on directory and file permissions. I hope this has cleared up any confusion you might have had as to how you read and interpret those, how you set those using the octal mode, and then how you set them using what I just simply refer to as the letter mode. All right, thank you guys so much for watching, and as always, I hope to see you in the next video.